All right, guys, Honors Chem, we are going to learn about strong acids and strong bases today. And I think I might put them in separate videos. And then today we are also going to probably talk about the dissociation constant of water. I might put that in a separate video as well. So let's dive into how we determine whether an acid is strong or weak. Okay, so in an earlier chapter, we discussed the ability of a solution to conduct electricity. Now, remember the conductivity demo? We said that those things that were able to conduct electricity in solution had to have ions that were able to be mobile. Remember that? They had mobile ions. Okay, so those that conducted electricity the best were able to produce ions that were easily dissolved in water, and because they were dissolved in water, they were able to move about that water. They were mobile. So what do you think electrical conductivity can tell us about the hydrogen ions? Those are ions and hydroxide ions that are in aqueous solutions. Do you think acids and bases conduct electricity? You bet they do. Okay, so acids. If I have a 0.1 molar, remember molar is moles per liter, hydrochloric acid solution, it will conduct electricity very, very well, okay? A 0.1 molar, notice the strength here is the same. A 0.1 molar solution of acetic acid, though, does not conduct electricity very well. So they're the same strength. So why does one conduct electricity really well and the other not? Obviously, the hydrochloric acid solution produces more ions than the acetic acid solution does. Okay, so when we put the hydrochloric acid in water, the hydrochloric acid will do what we call dissociate or ionize. Some people call it ionization because we're taking this covalently bound thing and we're making ions here. We have the chloride ion, and notice the hydrogen joins in with the water to make hydronium. So essentially we have hydrogen and chloride that are both dissolved in water. Okay, so when I have a strong acid, it ionizes completely. But notice for the hydrochloric, or not the hydrochloric acid, the acetic acid, notice this arrow. This arrow goes both ways, forwards and backwards, okay? So the hydrogen will join the water to make the hydronium ion. So that's where the hydrogen comes from. And then the acetate ion will dissociate, and this one will dissociate to form the acetate ion. But notice this reaction goes back and forth. So we get an equilibrium here. Now, remember from our discussion before that an equilibrium is a reaction that can go forward and backward, and eventually the change or the rate of the forward reaction is equal to the rate of the reverse reaction. So that's what happens when we have an equilibrium. So that means that this does not completely ionize, but the reaction up here with hydrochloric acid, it only goes one way. It only ionizes. It doesn't go back to form hydrogen chloride, okay? So notice the hydrochloric acid solution ionizes 100% of the time, while the acetic acid solution reaches an equilibrium. It does not ionize 100% of the time. So what determines whether an acid is a strong acid is whether it ionizes. So acids that ionize completely are strong acids. So in order to be a strong acid, I need it to ionize completely. It's going to just make ions when we put it in water. Because strong acids produce the maximum number of ions, they are good conductors of electricities. All other acids are weak. So if they do not ionize completely. So if I have an acid that does not ionize completely, It is a weak acid. So there are actually 7 strong acids. I have 6 listed here. I will add another here. So we have HClO4, which is perchloric acid. Okay, notice the hydrogen jumps on with the water to make hydronium, and then we have the perchlorate ion. Now, a lot of times we don't want to write all this water stuff because it just repeats over and over and over again. So to simplify this, we just really write the acid ionizing. So we would write perchloric acid ionizing into the hydrogen ion and the perchlorate ion. Okay? Because, we know that water's there and we don't really need to write the water in. Okay? We have hydroiodic acid. Once again, the hydrogen joins the water to make the hydronium, and then we get the iodide ion. The simplified version, we would just draw the hydrogen and the iodine ionizing into hydrogen and iodide. Hydrobromic, once again, the hydrogen joins the water to make hydronium, and then the bromide is off by itself. Simplified, we would just write it as HBr ionizing into the hydrogen ion and the bromide ion. Okay? So why don't you try these next few by yourselves, okay? And check in just a minute. Okay, so what did you have for hydrochloric acid? Did you have the hydrogen from the hydrochloric acid joining the water to make the hydronium ion? And then we'd have the chloride ion. Or simplified, we'd have hydrochloric ionizing to hydrogen and chloride. How'd you do on that one? Okay, sulfuric acid. Now notice there are 2 hydrogens here. Notice though that only the first hydrogen is strong. The second one is not. So the first one will join the water to make the hydronium ion, and then we will have the bisulfate ion left. So if I wanted to draw the strong acid reaction of sulfuric acid, I would have hydrogen and the bisulfate ion. Okay, how'd you do on that one? And then nitric acid, we have the hydrogen joining the water to make the hydronium ion, and the nitrate ion would be left by itself, or simplified, hydrogen or nitric acid going to make hydrogen and the nitrate ion. Now, there is one more that I would like to list here, and it is a cousin of the perchlorate ion. It is chloric acid. It is also a strong acid. So if I added this to water, I would get hydronium and the chlorate ion. Or if I wanted to simplify it, chloric acid would give me hydrogen and the chlorate ion. Okay? So let's list the 7 acids that are strong. All others are weak. Okay? So the strong acids, we have 3 that are binary. So we have hydrochloric, we have hydrobromic, and hydroiodic. Those are all strong. And yes, binary, they should all have aqueous by them. And then we have 4 ternary ones. We have perchloric, we have chloric, we have nitric, and we have the first hydrogen on sulfuric acid. Those are all the strong acids. These acids will dissociate 100% of the time, okay? They create a lot of ions when we have them in solution. All other acids are weak, okay? Acids that don't dissociate 100% of the time will have an equilibrium. They will go forward and backward. Okay, so let's look at this reaction. So in this forward reaction, what is donating the hydrogen? Okay, hopefully you saw that the acetic acid was donated the hydrogen. Okay, what is accepting the hydrogen? Hopefully you see that water is accepting that hydrogen. So the base is water. So in the reverse reaction, what acts as the acid? What's donating the hydrogen going this way? Notice that hydrogen gets donated back to the acetate ion. So then the reverse reaction, our acid is hydronium, and the base, what accepts the hydrogen, is the acetate ion. Okay, so here's our acid, here's our base, here's our conjugate acid, and here is our conjugate base. Okay, all right, so the above reaction, because we don't want to necessarily write out the waters, we are going to write it just like that, where we have the hydrogen coming off the acetate ion, creating the hydrogen ion and the acetate ion. Now, in reality, hydrogen ions or protons they're not by themselves in water. In reality, it really does make this hydronium ion, but it creates a lot of writing. And so for simplicity's sake, we do write it usually this way, just to make things simple. But notice that when we say hydrogen plus, it's actually hydronium. All right, that's enough for hydrogen or for strong acids. We are going to do another video and do strong bases. Have a great day. We'll see you later. Bye.